Hey guys, today we're going to talk about greatest common factors. Okay, so remember factors are numbers that divide evenly into another number. So like 2 and 3 are factors of 6 because 2 times 3 is 6. Okay, factors that are shared by 2 or more numbers are called common factors. So the greatest of the common factors is called the greatest common factor, or the GCF. So when you see GCF, that means the greatest common factor. The easiest way to find the greatest common factor of 2 or more numbers is by listing all the factors of each number from smallest to largest. So, here we go. We want to find the greatest common factor of 24 and 40. So the first thing we're going to do is we're going to list the factors of 24. So let's see, numbers that will go into 24. 1, 2, 3, 4, 6, 4 times 6 is 24, 3 times 8 is 24, 2 times 12 is 24, and 1 times 24 is 24. So there's all the factors of 24. Now we're going to list the factors of 40. So that would be 1 and 40, right? Some people like to work out and in. So 1 times 40 is 40. 2 and 20. 3 won't go into 40, but 4 will. 4 will go in there 10 times. 5 will go into 40 8 times. And that's all. Okay, so having trouble making 8s today. So the biggest common factor, which one is in common? The biggest one? Well, 1, but 2 is bigger, 4 is bigger, 8 is bigger, that's the biggest one. That's it. So the GCF is 8. Greatest common factor is 8. Okay, another way to find the greatest common factor is by using the prime factorization. So the GCF will be the product of all the common factors. Okay, so here we've got two numbers, 12 and 56, and we want to find the greatest common factor. So here's what we do, is we take 12 and we do a prime factorization. So 2 times 6, 2 times 3, so the prime factorization is going to be 2 times 2 times 3. Now 56, let's see, that's going to be 2 times 28, and that's going to be 2 times 14, and that's going to be 2 times 7. So the greatest, the prime factorization is 2 times 2 times 2 times 7. Now what we do is we go, okay, well, we got a 2 and a 2, we got another 2 and another 2. Now I got a 3 and I've got a 2 and a 7 over here, so 2 times 2 is 4. So 4 should be the greatest common factor of 12 and 56. So let's do it the other way and check and see. Right? So if I have 12, my factors are going to be 1, 2, 3, 4, 6, and 12. And my factors of 56 are going to be 1, 2, see 3 won't go in there, but 4 will. Times, let's see, 5 won't, 6 won't, 7 times 8 is 56. Let's see, 4 times 14 is 56, 2 times 28, and 1 times 56. So there's all my factors, okay, and the biggest one that they have in common, right there is 4. So it worked. Okay, I can do 3. I can find the greatest common factors of 3 numbers. So here I've got 14. All right, so my factors are 1, 2, 7, and 14. Then I've got 28. I've got 1, 2, 4, 7, 14, and 28. So I've got a couple of, I've got 2 and 7 and 14, but I got a third number, 49. It's got to be the same on all of them. So let's see, 1 times 49 is 49, and 7 times 7 is 49. So that's my only factors. So what is in common of all three of these? 7. So the GCF is 7. Now 14 looked like it was promising on the first two, but it's not in the third one, so it doesn't count. Okay, so I want you to find the greatest common factor of 20 and 45 using the prime factorization. Okay, so we'll pause the video here. You can go do that, and then you jump back on, and we'll see how you did. Okay, 20. I can split that up into 2 times 10. 10 I can split up into 2 times 5. So my prime factorization is 2 times 2 times 5. Now let's look at 45. Let's see, prime number that'll go in there. I could do 3. 3 times 15 is 45. 15 can be split up into 3 times 5. So it's 3 times 3 times 5. So which one's the greatest common factor? Well, there's only one that's common. That's 5. So the GCF is 5. Which pair of numbers has a GCF of 15? There might be more than one. Okay. So we look here, 10 and 15. Greatest common factor, huh? So I would take 10, I would probably do it this way. I'd say, well, the factors of 10 are 1, 2, 5, and 10. Okay, and the factors of 15 are 1, 3, 5, and 15. And neither one of these has a, well, this one has a factor of 15, but this one doesn't. So this one doesn't have one. So this one's out. Okay, let's look at 30. So 30, oh, now wait a minute. 30 I can write as 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. Okay, so 15 is definitely one here. So 60, does 60 go into 15? Or does 15 go into 60? Well, yeah, it does, actually. It's 4 times 15. So I can be done right there. I can say it's 15. But if I wrote these out, it'd be 1, 2, 3, 4, 5, 6. 6 times 10 is 60. 5 times 12 is 60. 4 times 15 is 60. 2 times 30 is 60. And 1 times 60 is 60. So 60 has a ton of factors. But it does have 15 in common. So that would be one of the answers right there. Okay. Let's look at 21 and 45. So 21 is going to be 1 and 21, and 3 and 7. So it doesn't even have a factor of 15, so I can just be done with this one because it's not going to have a factor of 15 at all. Okay, 45 and 75. So factors of 45 would be 1 and 45, 3 and 15, and 5 and 9. So 15 works here. Now I got to check 75. So let's see, 1 and 75. Let's see, 3 will go into 75. It'll go in 25 times. Okay, 4, 5. 5 will go into 75. Oh, 15 times. Oh, look at that. I don't even need to find the rest if there is anymore, because I already know that 15 works. So that's an answer too. So there's two answers, B and D. Okay, you're filling piñatas for your sister's birthday party. The list shows the gifts you're putting in the piñatas. You want identical groups of gifts in each piñata with no gifts left over. What is the greatest number of piñatas you can make? So if you got to look at the picture over here, it's a little bit hard to read on here, but you got 18 bottles of nail polish. $24 pairs of earrings. And 42 lollipops. Okay. So, what's the greatest number you can make without anything left over? So what we want to find is probably the greatest common factor here. So let's start with 18. 18 I can divide up into 1, 2, 3, 6, 9, and 18. So if I just had bottles of nail polish, I could do any one of those groups right there. Now, earrings. Well, I could do 1. There's 24 pairs of earrings, so I could do 1. I could divide up into 2s, 3s, 4s, 6s, 8s, 12s, and 24s. Okay, so right now, I can just look at this and say, well, let's see. The biggest number for these two is 6. So far I can make 6. Now, 42. Okay, I can do 1. I can do 2. I can do 3. I can't do 4, 5. 6 will go into 42 7 times. What is it? 42 divided by 3, 14. 2 times 21, and 1 times 42. Okay, so there's my possibilities. So the biggest one I can have here is 6, and I have a 6 there, so 6 is the answer. So I can make 6 piñatas. And have the same amount of stuff in each one. Okay, so here's what you're going to do on this assignment. There's the 2 pages. You're going to do 1 through 33, just the odd ones today. Have a great day. I'll see you in class.